Welcome everyone to the premiere of the new Simcenter SCADAS RS, our latest data acquisition system. It helps test and validation engineers to collect precise low data measurements anytime and anywhere under extreme conditions. We start the development of Simcenter SCADAS RS with the typical durability test campaign challenges in mind. Low data acquisition measurements are done on small and large prototypes, on public roads, on proving grounds, and even in remote areas and under extreme conditions. Test and validation engineers are challenged to collect more and more data under ever stricter deadlines. My name is Dirk, and I would like to present our new Simcenter SCADAS RS product to you. If you have any questions, please write them down in the live Q&A chat window. Simcenter SCADAS RS was designed as a powerful and precise data acquisition system with exactly these challenges in mind. It has a very rugged design, extreme flexibility in mounting, superior performance, and unparalleled connectivity. Let's take a closer look why these criteria are so important. My colleagues Shafak and Gert will provide more insight from a practical point of view.
Thanks, Dirk. Typically, durability load data acquisition campaigns are done in very tough conditions, especially in heavy equipment industries such as construction, mining equipment, or agricultural machinery. These tests are done in proving ground or in the field conditions under extreme environments. Since these machines are designed to work in such extreme environments where we experience quite some water, dust, and mud, your data acquisition system should also be able to withstand these extreme conditions. It will not be a pleasant condition if you break your measurement system in the middle of a testing campaign, let's say. Here we see an example of agricultural machinery which is tested in a field where we see quite some mud. So typically, these tests are done in one-shot conditions. Once the crops have been harvested, then you need to wait for another year in order to test the machine in the same environment. But the mud is not the only thing that we should consider. We should also take into account of high shocks and vibrations that these machines undergo during the operation, because this might also have a negative effect on your data acquisition system, let's say. But the heavy equipment industry is not the only one where the ruggedness is very important. There are others.
No, indeed, Shafak. Also in the automotive and transportation industry, durability test campaigns are performed in quite some challenging test conditions. The wide operating temperature range is one of those conditions. When performing a test campaign on a proving ground in South Africa, for example, the outside temperature can easily go up to 40 or 50 degrees Celsius. So you can imagine how hot it will get inside the vehicle and in which high temperature the data acquisition system needs to work in. But durability test campaigns are sometimes also performed in quite some low temperature environments, on a test track in Sweden, for example. In the evening and during the night, the temperature can easily drop below -10 or -20 degrees Celsius. And the next morning, the test engineer does not want to wait until the temperature rises above the freezing temperature before starting up his measurement system. Another challenge is the power supply for your data acquisition system. First of all, you need to make sure that your system can deliver enough and stable power to all of your sensors. Secondly, you also want to avoid that during the actual measurement, your measurement system shuts down unwantedly due to power loss, causing corrupted data or even loss of data. As a test engineer, you really want to avoid costly test reruns due to one of those reasons.
We solve this by making a very rugged design. This way, Simcenter SCADAS RS can be used from -40 degrees to +65 degrees centigrade. It is IP66 and 67 rated against water and dust, and it is capable to withstand high loads, up to 10 G RMS and 100 G shock. But ruggedness is more than the ability to withstand high vibration or shock loads, or protection against water and dust, or the ability to operate in a large temperature range. Power sources from vehicles or machines are not designed for powering data acquisition systems. For this purpose, we designed the Simcenter SCADAS RS UPS unit. It provides stable output power from unregulated input DC sources. If you need more power, simply add more UPS units to your daisy chain. Next to that, a remote on-off functionality allows you to start the UPS upon key switch activation of the engine. This way, the Simcenter SCADAS RS system boots at the moment of engine start and is ready to take the data from the very beginning of the test.
Another typical challenge during the instrumentation phase of a durability test campaign is how and where to mount the data acquisition device. The fixation of the data acquisition system on a large machine is not always very straightforward. Sometimes there is not enough space inside the machine. So in such conditions, you need to put it on outside of the machine. But these outside locations are not always easy to reach, and there might not be even a place to fix the device on the outside of the machine. On large machines like excavators or tractors and so on, the test engineers are also struggling with the cable instrumentation. Another example will be from the railway industry, where the locomotive and the wagons will be so far from each other, so that we need very long cables to use on such applications. So the long cables would cost like a little fortune. And at the same time, I should also indicate that it will be very time consuming to position all these cables on the structure in a secured way. And the long cables are quite sensitive to noise pickup, voltage drop, and so on. And this all will be affecting your data quality.
On smaller sized vehicles like passenger cars, the distance between your measurement system and the sensors is of course not so big as on an excavator or a large truck. But nevertheless, test engineers are always looking for ways to simplify the cable instrumentation. So bringing the signal conditioning closer to the sensors will certainly also bring some benefits for the automotive industry. As in the heavy equipment industry, there sometimes is not enough space inside the vehicle to put your complete measurement system. Think of the small trunk of a IA car model. So the ability to distribute your system over 2 or more locations in the vehicle will simplify things. And finally, besides the length of the cable, also the number of cables can be a challenge. We see in some cases, customers need to plug in a separate cable for power and data stream. They need to add some extra adapter cables for signal conditioning. They need to plug in cables in the front and in the back of the measurement system, which is not always accessible. So simplifying all this will substantially minimize the instrumentation time for them.
We designed a rugged slide and latch mechanism to mount units on top of each other without any tools and easily unmount them again. The slide and latch mechanism is designed with the same criteria for shock and vibration ruggedness. Units can be mounted in different ways on the vehicle. You can mount units vertically in different layers and strap them using strap belts to the structure. Units can also be mounted horizontally using the same strap belts, but now in the other direction, and again tightening them firmly to the vehicle. Alternatively, it's possible to use mounting holes in the back of the units to mount each unit firmly on a structure. There are an infinite number of other mounting options. We also provide an additional tool, a bracket, to mount units in a back-to-back configuration, like this, or even in a sideways configuration, like this. It is also possible to mount units horizontally on a structure by means of this bracket. Connecting units is as simple as plugging in this daisy chain cable. It provides both power and data between each of the units. Adding units can be done by connecting them through the same daisy chain cable. We provide cables in different lengths. Short cables for stacking between units mounted on top of each other or close together. Longer cables of 1 meter up to 50 meters for more distributed system configurations. These different cable lengths allow you to configure a system any way you want, as a centralized system, all units close together, to an entirely distributed system, where units are located apart from each other with short signal cables to the analog sensors. With its flexible mounting options, different configurations are possible on prototype machines and vehicles with very different sizes.
When you talk about durability testing, you talk about acquiring and synchronizing a wide range of different types of sensors. You talk about measuring strain gauges, accelerometers, displacement sensors, load cells, wheel force transducers, GPS location, and so on. Now, all of these sensors have their own signal conditioning, and in most cases, you need a different dedicated acquisition device or unit to measure each of those sensors. But of course, you want to limit the number of devices or units which you have inside your vehicle. They all take up a lot of space, they need to be fixed, they can break, and so on. Another requirement for durability testing is the ability to measure the data that is coming from vehicle digital buses. For example, the angle of the steering wheel, the temperature of the exhaust, and so on. Now, this information is maybe not essential to calculate the damage or lifetime of your component or vehicle. It gives very valuable insights to the test engineer on the conditions on which the loads were measured on the vehicle. Durability testing is not only about doing measurements outside on the road, but also about transferring this road data to a test rig. So a fundamental part of a durability measurement system is the connectivity to test benches, the ability to connect and transfer the load data from the vehicle to the controller of the test bench.
Beside all these different types of sensors as indicated by Gert, heavy equipment manufacturers, they also measure some more specific sensors, like pressure transducers, digital in, or more dedicated load cells. So what I see so far as a common practice, most of them, they have one dedicated main data acquisition device, and next to that, they have some other devices in order to capture the data from these different type of sensors. So measuring video images in another example, we see more and more customers also want to record what is happening around the machine during the actual measurement. When they notice some strange behavior afterwards in data, they can immediately check the video images in order to see if this phenomena happened due to the sensor anomaly or due to the field condition itself. A trend in durability testing is to further automate specific steps of the process. Some of our customers, for example, want the acquisition system to automatically start and stop the measurement when the machine starts without having interactions from the operators or the engineer, let's say. And instead of having the engineer sitting inside the cabin for the whole measurement, which might be quite a long time actually, so they want to save the data on the acquisition device itself.
Simcenter SCADAS RS supports all common sensor types like strain gauges, accelerometers, force cells, pressure sensors, string pods, and so on. Digital sensors such as quadrature encoders are also typically used and supported on Simcenter SCADAS RS. It also connects to typical digital vehicle buses such as CAN 2.0, CAN-FD, XCP, and it interfaces with real-time buses such as EtherCAT. A rack unit acts as a central location where signals from individual conditioning units are collected and can be stored safely on an onboard SSD or streamed to an external PC. To ensure compatibility, we standardize on the same connector between all conditioning units. So a sensor wired for this 24-channel sensor conditioning unit can also be connected to a 12-channel universal conditioning unit using the same cable. In line with the rugged design, this connector is IP67 rated, shock and vibration tested, and works from -40 to +65 degrees Celsius. Even more, it is a connector for measurement equipment designed for 5000 mating cycles without loss in quality of the electric connection.
A last challenge that I would like to mention is the access to your data acquisition system. Once the vehicle is instrumented with the required sensors, you need to set up the sensor and measurement parameters and check if everything is working okay before you go to the proving ground. In that case, you typically need a dedicated, most probably Windows-based PC with the acquisition software installed on it. You need to have the right licenses to run that software. You need a network cable or other type of cable to connect to your measurement system and so on. So this is not so obvious. And once you're connected, in many cases, there is also only one person at the same time that can access the data that is coming in. So this means that the sensor setup and verification needs to happen in a sequential way, so sensor after sensor. You could win a lot of time if multiple users can have access to the measurement system and work in parallel on different parts of the instrumentation. When the setup is checked and approved, you can go to the proving ground and do the actual measurements. But the challenge that we see with a lot of our typical customers is the limited or incomplete sensor information that they get during the actual measurement. Since more and more customers do not want to have an engineer or a PC inside the vehicle, the only feedback on the sensors that the driver gets to decide if the measurement was okay or not okay is in best case the colored LEDs on the acquisition device itself. So when then the test engineer afterwards determines that one or more measurements were not okay, this will lead to costly test reruns.
The restricted access to the measurement system is also another pain for heavy equipment industry. You can imagine that in this case, you are doing a measurement in the middle of nowhere in a big muddy field, let's say. So having a crash-sensitive PC would not be a good idea, I think. And where will you be standing, by the way? Or sitting inside the cabin where you have very limited space. And also, if you stand next to the machine, I think that will be also quite problematic because most probably there will be a need for a physical cable to connect from your side to the measurement device, let's say. For that specific reason, actually, most of the test engineers prefer the operator to do the acquisition campaign himself. We see a lot of them also would like to have a second eye who is looking together to the data for the main test in order to evaluate the data. But most of the time, these engineers, second eye engineers, are located somewhere else, not in the measurement location. So it might be in the office, which might be again hundreds of kilometers away from the measurement location. So as said before, there is a trend in the durability testing to further automate specific tests of the process. We see more and more cases, there is a desire to record the data autonomously. So the driver even does not need to worry about the data acquisition device, let's say. So in this case, the measurement system should do the start and stopping the measurement when the machine starts. This actually requires some intelligent triggering functions on the data acquisition system. We also have requests from our customers who want to upload the data to a company server or to a company network with an autonomous way, rather than doing it manually by copying the data to these servers, let's say. And by this way, the other engineers in the office can further work in the data, or let's say further process the data to do to tackle some other challenges on the data. And all this will actually eliminate the need for on-site presence of multiple people during the test, let's say.
The last design criterion of Simcenter SCADAS RS that I want to show is its unparalleled connectivity. First of all, you can connect to Simcenter SCADAS RS units using any device, a PC, a tablet, or even a smartphone, using wired or wireless connection. It's possible to access the onboard application on the Simcenter SCADAS RS units using a simple internet browser. Thanks to its wired and wireless connection options, Simcenter SCADAS RS can easily be connected to company networks, but also over modem connections to cellular networks. So a Simcenter SCADAS RS system can easily be accessed even when it's at very remote locations over extremely long distances. Simcenter SCADAS RS can also be configured to offload data in different ways, manually at the end of the working day or even after each run. But downloads can also be scheduled automatically, for example, when the system comes in reach of known Wi-Fi networks or overnight when connected to a public network after a day of testing. Secondly, you can connect to the same Simcenter SCADAS RS system with more than one device at the same time. Changes on one device are applied also on the other devices. And finally, settings are also stored on the individual Simcenter SCADAS RS units. And this opens up possibilities to instrument one single system with multiple people at the same time in a joint team, or in parallel by two teams, for example, or more, that instrument each their part of the system, a front axle, a cabin, a rear axle, and by combining afterwards all these individual parts together and connecting the SCADAS RS units through their daisy chain, reading out the settings and making the system ready to start the measurements. In summary, Simcenter SCADAS RS rugged design, extreme flexibility, superior performance and unparalleled connectivity facilitate faster and more cost-effective execution of even the most demanding test campaign. It can help you too in making your daily test job faster and more efficient. In case of questions, please enter them in the chat window or contact your local Siemens representative. For more information, visit our website and don't miss out on the upcoming webinar. You will find the links in the description box. So thanks for watching and stay tuned for more news on Simcenter SCADAS RS.